talking about solving systems with three planes here, okay? And it looks to be, this will be our last section in Chapter 8. So once you kind of got all this all figured out, you can maybe sign up for a test for this stuff, okay? So, as always, we'll start by looking at the possible solutions. So, a system with three planes is going to be, you're going to basically have, if this is very much like yesterday's system, or whatever day that was, where you have two planes that intersect in a line like this, okay? And then you actually have a third plane that kind of comes through like this, right? Down like that, and over here, and so forth. So would be another line point where they intersect right there, and the combination of all of these would end up being a point, right? Like that. All right. Now I would need to make some changes on my drawing here, but it's more or less like that one right there. And I think I'm going to need to get rid of that line, and I'll put it back here and here. Oh, actually, we would have maybe a dotted line going down like that. And let's go, we'll erase this one and that one. So it would be something along those lines there. That would be more or less the location where they intersect. Now my diagram's a little bit funny. I made it so that the planes themselves, excuse me, will appear to be perpendicular, but they don't necessarily have to be perpendicular, okay? All right. Now, in this scenario, all planes are non-parallel, okay? So no plane is parallel to another, right? And then also if I take their normals and I cross them and then dot them. So remember, I have three planes, so I have three normals. So I first cross product two of them and then dot the third. I get a non-zero number, okay? In which case I know I have a single point solution. It's very nice, actually, because then in the other scenarios where I've got, if I take my cross product here and here, and my dot product here and here, I actually get a zero, okay? In which case I know I don't have, a single point solution, okay? And I'd have a line solution instead, or no solution at all, okay? Now, a line solution ends up looking something kind of like this, where you've got your two planes here starting, and I'm going to put in a third one, right? I'm going to do something like, let me cross that off. Go out a little further and go like that. They intersect at this line here, okay? And let's go with that. There we go. They intersect at this line, okay? And now, let's pretend like I actually now have my third plane, and it also intersects here, for example, okay? something along those lines. And basically you would have a line solution here. Okay, if that were the case. All right. Now, lastly, there is the no solution one. And there is actually a wide range of no solution possibilities, okay? And I'm not going to write them all down because there's just a bunch of them. So I want to kind of just I'll go through a few of these, maybe in a separate little video, okay? What I'd like to focus on is the single point solution and the line solution, okay? For the no solution one, you really have to do quite a bit of analysis on the slopes and whether or not certain things are or are not parallel, right? So, for example, if I've got, two planes that are parallel, like this, one above the other, and then I have a third plane that's kind of going down like this and intersects both of them at a line here and a line there. You might think, oh, well, I've got a double line solution. But remember, it's not where maybe one plane intersects the other. It's where the only solutions are where all three planes exist at the same location. So that's why here you can have a single point solution. Here you can have a line solution. This would actually be a no solution. This one here that I've drawn, okay? There's other variations on this, okay? And that would be something like, I guess I'm just going to go for it here. I'm going to put it all in the same video. This one's really tough to draw. Kind of goes like this, and then we might have another plane like this, right? That goes down like that. And then we might even have a third plane here that's kind of like crazy going in like this, okay, and doing its thing in this area here, right? Oh, I'm not sure I drew. So basically you would have three lines, 1, 2, 3 lines where they all intersect. I don't know if I drew that very well. By the way, if you're looking, you can, on page 485, there's nice diagrams that are a little bit better than mine here that show all of these different variations. Other possible no solutions would be things like maybe just, a plane, and a plane like that. Or another one would be a plane and a plane. And then the other plane is actually sort of a identical plane as the other one, but it's not. Remember how you can have two planes that are exactly the same plane but written differently? This would be still a no solution. So two planes that are equal and then a third plane that's parallel and off to the other side, okay? You could have that as well. These would all be no solutions, though, because remember, a solution is only where all three planes exist at the same time, right? Okay, and then there's one special one where you have a full plane solution, and that's where all planes are equal, just completely equal, okay? So these solutions over here, by the way, you're going to start discovering that some of our planes here are parallel, okay? For example, here you're going to have plane 1 is parallel to plane 2, right? If this is 1 and this is 2. In this one, you're going to have plane 1, 2, and 3 are all parallel. As here, you're going to have all 3 are parallel, right, as well. In this one, they're going to have no parallel planes, okay? So you're going to have to try and, like, hash out what's going on. So with these things. So notice what I'm talking about here. I'm talking about the parallelness of things, right? And I'm also talking about the triple scalar product, which is this thing. So that's going to be our first steps when attempting to analyze a system of 3 equations, okay? So I'm going to go ahead and determine if I have a solution here by checking for parallelness first, okay? So I'll start that. I'll check for parallels, okay? So I'm going to do plane 1 and plane 2 parallel. Well, let's see. Is 2 over 3 equal to 1 over 4? No. Remember, when checking for parallel, you just do ratios of the components. And as soon as you get a non-equal sign, you know that they're not parallel. So I'm going to go ahead and write. Okay. Is plane 1 parallel to plane 3? Plane 1, 3. Well, I'm going to check 2 over 1. Is that equal to 1 over 2, negative 2? No. So therefore, these guys are not parallel either. And then finally, I'm going to check to see if plane 2 is parallel to plane 3. You have to do 3 checks here. 1 with 2, 1 with 3, and 2 with 3. So you get all combinations there. And so basically, is 3 over 1 equal to 4 over 2? No. Okay. So I've got no parallelness. So basically what that means is I have only 3 options now. I have this, or this, okay? So now, if you have no parallels, then you have basically 3 possibilities. This one, or this one. Notice all these other ones have some kind of parallel thing going on. These ones, these ones, these ones. So now what I'm going to do is I'm going to do the triple scalar product, where I'm going to take the cross products of the normals and then dot it with the last normal, the other one. And if I get a non-zero, I know I have this. If I get a 0, I actually know I have either this one or this one, okay? So stay focused on what's going on here, and you'll kind of see how this pans out. And so now I'm going to take the normals and I'm going to cross them and then dot them with the last one. So I'm going to do cross product of these guys. So I'm going to do N1 cross N2. I'm going to dot it with N3 there. Okay. And so I'm going to do my X, Y, Z. And so my dot product, or my cross product, is going to be 2, 1, 6, 2, 1, 6, and then it's going to be 3, 4, 3, 3, 4, 3. So I'm going to go ahead and do this cross product. So I'm going to get 1 times 3, which is 3, minus 6 times 4, which is 24. So it's giving me a negative 21 for my X component. My Y component is 6 times 3, or 18, minus 2 times 3, or 6. So 18 minus 6, I'm guessing at 12 there. Now my Z component is 2 times 4, which is 8, and then I've got 3 times 1, which is 3. So 8 minus 3 giving me a 5. Now I have to dot this with the last, which is 1, negative 2, and negative 4. Dotting this with the last normal, which is 1, negative 2, negative 4. Taking this dot product, it looks to be like I'm going to get a negative number, right? Negative 21 minus 24 minus 20. This is non-zero. So I basically now have what have I done? I have determined essentially that the thing here is the first one, okay? So this non-zero right there, I'm trying to find a different color. This fact that it is not 0, right? I've basically guaranteed that I have that first one, okay? So now that I've guaranteed that I have the first one, let's go ahead and solve it. That's how these work, remember. You do a little bit of preliminary work, and you try and determine what situation and scenario that you have, okay? Once you've decided that, you then adopt the problem-solving technique that I show you, okay? So now that I've decided I have the point solution, the problem-solving technique is as follows, okay? So I'm going to take plane 1. Let me go with a nice blue here. I'm going to do plane 1. I'm going to write it down. So it's going to be 2x plus y plus 6z minus 7 equals 0. I'm going to take plane 2, write it down, which is 3x plus 4y plus 3z plus 8 equals 0. Then I'm going to take plane 1, right? Again, 2x plus y plus 6z minus 7 equals 0. And then I'm going to take plane 3, which is x minus 2y minus 4z minus 9, which is 0. All right? And now, so this is what you want to do now is you want to decide to eliminate one of the variables. And you're going to eliminate the same variable in both equations. It looks to me like y is going to be an easy elimination here. You see this y, if I eliminate y here, and if I eliminate y here, I should be okay. And then what I'll have is I'll have two equations down here. You'll see how this is going to work, all right? So I'm going to give myself a little bit more room here. Let me do a couple of enters, enter. Okay, perfect. There's a little bit more room. Okay, so in order to eliminate y in this equation, I have to take this whole equation and multiply it by 4, and then subtract from it this equation. So basically, I'm taking 4 times plane 1, and I'm subtracting plane 2. Okay? So that means I'm doing 4 times 2, which is 8, minus 3, giving me a 5. Then I'm taking 4 times y, which is 4y, and then 4y minus 4y is nothing, so my y's go away. Now I'm taking 4 times 6, which is 24, and then I'm subtracting 3, which is 21z. So I'm getting a plus 21z. Now I'm taking 4 times 7, which is 28. Is that right? 4 times 7, yes, 28, and then I'm subtracting 8, right? So 28, it's a negative 28 actually, and then I'm subtracting 8. So what am I going to get there? Let's see, 28, 36. So minus 36 equals 0. All right. And then my y's, they were supposed to be there, but they're now not there. Okay. So I'm going to rewrite that was 5x plus 21z. Okay, so there's one equation. All right, and notice the y's have now been eliminated. Okay, now I'm going to do the same thing over here on this side, and I'm going to eliminate the y's. But now in this case, I'm going to multiply the top equation by 2, and I'm going to add the bottom equation. So I'm going to write 2 times plane 1 plus plane 3. All right, I guess I could have written it like this. I didn't need to. Sorry, it's 2 times plane 1 plus plane 3. So I'm getting 2 times 2x is 4x plus another x is 5x. Cool. And then I'm getting 2 times y, which is 2y, plus a negative 2y. 2 times y plus a negative 0. And I'm getting 2 times 6, which is 12, plus a negative 4, so 12 minus 4, giving me an 8z, so plus 8z. And then 2 times 7 is 14, so negative 14 minus 9, right? 23, I'm getting negative 23. All right, so now what I've got here is something pretty interesting. I've basically turned my equations into with only x's and z's in them. So now look at this. I'm going to do the same thing. I'm going to bring these equations together down. Maybe I'm going to bring this guy over here, right? And I'm going to write him over there. So I'm going to write 5x plus 8z minus 23 equals 0. And now I'm going to eliminate the x's because this is nice and convenient, right? So right here, I'm just going to take the the difference between these two equations, because 5x minus 5x is 0. 21z minus 8z is, what am I going to be doing? 13, is that right? 13z? Oh my, this is going to get wild. And then I've got 36 negative minus or plus 23. Oh, giving me a negative 13. And it looks like z is, if I subtract over 13, add over 13, z is 1. Oh my, that's spectacular. Now that z is 1, I'm going to take that information and I'm going to plug it into this section. And I'm going to say that 5 times x plus 8 times 1 minus 23 should be correct. And so now I'm going to take this 8 minus 23, giving me, what is that, 15? Oh, this is working out nicely. 15 here, right? Negative 15, and then I pass it over, or positive 15, and then I divide by 5. So I'm getting x equals 15 divided by 5, or x equals 3. Spectacular. And now, lastly, I'm going to find my y, which I eliminated, remember, at the very, very beginning. So I'm going to go back and I'm going to get plane 3, or maybe I'll get plane 1. I'm going to get plane 1, which is 2x, right? Oops, but x is not 1, x is 3. Plus y plus 6z, z is 1, minus 7 equals 0. This is plane 1, by the way. And there, I should be able to determine my y value, okay? So I'm going to get 7 and 6, this is negative 1 here. And then another positive 6, giving me about a 5 here. Is that right? No. Yes. 6 and 6 is 12. Minus 7 is 5. Positive 5. Pass it over. It turns out to be a negative 5. So therefore, y equals a negative 5 in that equation there. And there it is. That's my point of intersection. It's 3, comma, negative 5, comma, 1. Okay? And that's how you do those ones there. If you get no parallel stuff, okay, and then you also get a non-zero triple scalar product, then you're good to go. You just do all this stuff in blue here, and you find a point. Now what you can do is you can take this point, you can plug it back into each one of these planes, and you'll find that it actually gives you a correct answer, right? I'm pretty sure that that's right, so I'm not going to check that out. Now we're going to do this question here, all right? So let me know if I made a mistake on that one, by the way. So let's go with get a nice little color here. Black. Actually, I haven't done black in a long time there. There we go. All right. So remember, what we first do is we check to see if anything is parallel. All right. So I'm going to do plane 4 parallel with plane 5. And so I'm going to get 1 over 1. And then negative 5 over 7, not true. Okay. Plane, so they're not parallel. Plane 4 with plane 6. I'm going to do 1 over 8 and 5 over 5. 1 over 8 is not equal to 5 over 5, and so they are not parallel. And in the end, you don't have to write all this stuff down. I'm just writing it down in the notes. Let me do plane 4, 5, 4, 6. Now I just need plane 5 with plane 6. Okay. Is 5 parallel with 6? I can see that it's not, because I got 1 over 8 is not equal to 7 over 5, right? There. Now I'm going to do the triple scalar product. So I'm going to do x, y, z, x, y, z. And I'm going to take the normal to plane 4, which is 1, negative 5, 2,